So in my presentation, I will address several but interconnected topics. So the theme that intertwines these topics is the relationship between theory and practice in the field of digital technologies applied to archaeology. Specifically, this presentation consists of three sections. First of all, I will talk about the objectives of the workshop. Then I will briefly illustrate one of the generating elements of this initiative, namely Marie Curie project, titled BiGAr, BIM, and BIS integration for archaeology, focusing particularly on some significant results of this research. And then I will return to the central element of the presentation, the relationship between theory and methods in digital archaeology, briefly introducing the theme that will be addressed later today.
Vogliamo abbassare un po' la luce perché non
Certo.
sì.
Smeglio. Alessandro, dobbiamo spegnere
No, è già meglio. Sì.
Forse un po' troppo. Vedo qua. So our first objective was to bring together experts in digital archaeology to discuss issues related to this field. Each of you comes from different fields that only partially overlap. Field survey, excavation, rock art study, architectural archaeology, and finally museology. From this point of view, therefore, the objective, which can be said to have been fully achieved, was to gather the perspective of leading researchers in different sectors of digital archaeology. Thus, the title of this workshop, New Frontiers in Digital Field Archaeology, Reshaping Practices Through Digital Strategies, highlights one of the main sources of digital data we process in archaeology, the fieldwork. However, the workshop then expands to other sectors, such as the communication of excavation data and their valorization. Additionally, I would like to focus on a term we decided to include in the subtitle, digital strategies. Every methodological leap in our workflows requires an extra investment of resources in terms of technology, time, tools, people, and knowledge. Today, therefore, we will have the opportunity to reflect not only on which technology is best suited to achieve our research objectives, but also on how several research tools several research groups have structured long-term strategies for experimenting with new digital workflows, capable of combining the needs of research, the experimentation of new technical solutions, and the available resources in terms of time and funds. Secondly, as anticipated, this workshop constitutes one of the concluding events of my Marie Curie Fellowship, centered on the BiGAr project, which stands for BIM and GIS integration for archaeology, which aims to innovate the methodology of archaeological research by developing new methods of integration between building information model, BIM, and geographical information system, GIS, to document the 4 dimensions of archaeological evidence, as well as the information traditionally associated with it, such as textual or raster data. And so the second objective of this meeting is to create an opportunity to discuss some of the central themes of this project, such as the concept of level of detail and the resolution of digital reconstructions, the concept of level of information need while developing a digital output, the workflows from field to museum, digital challenges, and more. Within the BiGAr project, we have tried to experiment with new ways of managing excavation information, in particularly enabling the representation of the volumes of the archaeological evidence and integration with other data normally produced during our investigation, such as text, database, photographs, and other parser data. To do this, we have explored BIM technologies and the possibility of integration between these and the related formats, such as IFC, Industry Foundation Classes, one of the formats specific to the BIM technology, a standard that allows for the description of built structures and GIS technologies with a preference, when possible, for free and open source software. The activities during the project have thus focused particularly on some areas, including the method of creating excavation volumes, the automation of digital processing through the drafting of Python scripts, the analysis of the consistency of digital products in terms of both topology and adherence to archaeological evidence, and finally, the analysis of excavation and documentation workflows currently practiced, thereby arriving at the analysis of the theoretical aspects related to these applications. The interest in BIM started from the observation that this technology allows to integrating geometric and semantic information. However, while it allows for managing detailed data at the local level, BIM is less suitable for managing geographic data at the landscape level. It lacks, for example, enough support for geospatial analysis, which is instead a capability of GIS, which can also manage geographic visualization much more easily. But at the same time, GIS lacks the level of detail achievable by BIM. Hence, the potential to integrate BIM and GIS, making it possible to exchange between different formats, such as IFC, CTGML, and shapefile. Regarding this general workflow, I would like in particular to focus on some of the processes we have experimented with, specifically those connected to the semi-automated segmentation of point clouds and the subsequent creation of columns. This example, in the slide, we have a series of tasks that allowed us to move from the point cloud of a surface composed of multiple stratigraphic units to the point cloud composed of both the surfaces of the stratigraphic unit, the upper and the lower surfaces. This is the fill of medieval peat, which was cut by a more recent SU. The final result was achieved through a semi-automated process that utilized the cloud compare libraries in Python. And here a second step, which shows one of the possible workflow to obtain a solid in a BIM environment, namely a solid in IFC format. This path was created using visual programming software Dynamo, which combines a series of functions using the Iron Python programming language, a web-compliant version of Python. However, before this, it was necessary to check the correctness of our meshes, the direction of normals, the problem that can create non-manifold geometries, such as disconnected vertices and edges, internal faces, areas with no thickness, and so on. This is possible within Blender software, where these processes can also be semi-automated with the Blender module in Python. However, as I said, during this workshop, we will not only talk about documentation methods. As anticipated, indeed, I would like to focus on the relationship between theory and digital archaeology, which connects the themes of the BiGAr project with today's presentations. The theoretical issue is neither absent nor can it be. In the past, two opposing views on digital advances in archaeology have been highlighted. The first, that these developments are essentially methodological. They provide a series of tools to solve problems generated by research. In this view, digital techniques are theoretical, or even anti-theoretical, or multi-theoretical, meaning they can be used to support several theoretical positions. And here, as the justification of the cartoon I've included in the slide, I borrowed this consideration from an article written by Dr. Jeremy Haggett, Senior Research Fellow at Glasgow University, who said, this conception of the computer as a tool carries within it a tendency to make technology seem neutral. The tool is neither good nor bad, but is capable of being put to good or bad use. It is the equivalent of the aphorism that guns do not kill people. People kill people. What gives the tool direction is the user. The tool is simply how we, as users, achieve our desired objectives. Our focus is therefore on how the tool is implemented or used, an approach which can support a view of computer-based tools as theoretically neutral. The second view, which I somewhat share, is that theoretical developments have influenced the development of theory, thanks to the application that were previously inaccessible. At the extreme end of this point of view are the consideration expressed by the archaeologist Giorgio Buccellati. The archaeological record is intrinsically digital, not in the sense that it turns digital once the data have been entered and processed, but more radically in the sense that it is by its very nature digital, in its genesis and its structure. I've included this quote here as a sort of provocation. Indeed, already Gavin Lucas has criticized this view of archaeology natively digital, stating we need to remind ourselves that the digital practices associated with databases are very different operations from writing a story or constructing an argument. From this point of view, it strikes me that the titles of two contributions today end with a question mark that expresses the need to analyze current practices or documentation standards that are under experimentation, with the goal of avoiding what happens as this concludes policy. As the anthropologist Clyde Clackham pointed out almost a century ago, if we want to allow ourselves to grow intellectually, we must avoid sticking to our prejudices and biases, exposing them to the scrutiny and critique. This thought was later taken up by masters of theoretical discourse, such as Gavin Lucas or Matthew Johnson. In particular, Johnson concluded his reasoning with an extreme assumption that all of us archaeologists are theorists, willingly or not, consciously or not. The reflection that guides the need to define effective and shareable standards within documentation practices, now deeply connected to digital technologies, is thus linked to a theoretical reflection on the practices of our discipline and the definition of its future objectives. Not that in the past there have been no archaeologists who have reflected on the evaluation and synthesis of digital data and the relationship between theory and digital archaeology. From the first articles on GIS, such as those by Juan Anton Barceló, Maria Palares, Marcos Llovera, Paola Moscati, or the papers delivered within the CAA, such as those by Gary Locke, Walt Weiss, Sarah Perry, and James Stewart Taylor, or the volumes by Locke and Brown on theory and practice in archaeological computing, and that of Evans and Daly, digital archaeology, bridging method and theory. The contributions of critical analysis of practices have then increased in the last 15 years, affecting several sectors of archaeology, including visualization, modeling, virtual reality, big data, and more. However, just as Sarah Perry and James Stewart Taylor said, the ubiquity of computational approaches in archaeology still seems little understood. And shortly after, in another passage, why are they, the computational approaches in archaeology, regularly perceived as theoretical? Let leave this question unanswered for a moment and highlight in the meantime that the problem of new technologies, as in the past, interests the great paradigms of theory. Processual archaeology, as we all know, promoted the use of digital technologies for the creation of GIS, for modeling and simulation, and for seeking tools to develop systemic and behavioral theories. In contrast, post-processual archaeology holds that the primary method for understanding an individual is interpretation. Thus, post-processual archaeology requires computing to be ancillary and focused on the process of doing archaeology in the field, as Zubro said. Another position that deserves probably mention is that developed from the 1990s by cognitive archaeology, which believed that individuals share similar thoughts, including common sense knowledge and an understanding of causation. For cognitive archaeologists, digital archaeology must try to model the goals of past individuals through the modeling of processes and memory, retracing the key points of artificial intelligence. However, regarding the more general paradigms of archaeology, I would support one consideration. Despite appearances, I don't think digital archaeology can be an ally of empiricist approaches anymore. We all know that the increased focus on big data and science in archaeology regarding GIS and spatial analysis, chemical physical analysis, and digital technologies had suggested the possibility of a theory-free and data-driven archaeology, where the data can speak for themselves. However, our digital data is far from perfection. Despite the constant race towards increasingly accurate models and larger data set, I think that the high resolution achieved by our workflows can teach us precisely that the data collected are not a faithful copy of reality. The product of the photogrammetric survey, for example, can lead to different results depending on various environmental factors, as well as the precision of some practices performed in the field. Therefore, this data alone cannot, or better, should not guide our research. They need to be examined, verified, corrected, and finally interpreted. They must be reread from a theoretical perspective. Thus, digital archaeology may have introduced a potential new barrier between the archaeologist and the excavated contexts, which they risks being examined more at the workstation than in person. A barrier that should be reduced as much as possible by revising the workflows to bring the archaeologists back to interpreting evidence in the field. These objectives can be better managed than however, while the need to reach an interpretation in the field remains, having a digital private allows us to return to the evidence even later, possibly even after it has been excavated, the evidence has been excavated. It may have happened to you also to notice a detail in an orthophoto or a model that you missed in the field, or a color difference that was not visible from the ground, but clearly emerges from the orthophoto of an area. As Haggett already noted, this is one of the characteristics of digital technologies, which enter all the phases of the archaeological knowledge, from data collection to interpretation and analysis, unlike other archaeologists' tools, such as trowel or a total station. In conclusion, the answer to the question posed by Sarah Perry and James Taylor, why are computational approaches regularly perceived as theoretical, includes an omission of thought, which seems understandable. They said, even if digital archaeology is in a position to lead archaeological theorization overall, the bar is set too low. Not only are our expectations of the technology deficient, but so too are our assumptions about digital practitioners, digital research potential, and the social-political impacts and application of digital work. In any case, I think it is inevitable that new theoretical approaches will be deeply influenced by digital technologies, and our relationship with them. Or perhaps it is better to say they must be influenced by them if they really want to constitute a new paradigm of thoughts, research, and application. The theoretical implications of digital archaeology are particularly central in this morning's presentations. This session will be moderated by Andrea Argenti, Professor of Archaeology at the University of Bologna. Conversely, the afternoon session presentation will focus on some technical aspects related to workflows applied in different areas of research, such as landscape archaeology or architectural analysis. This session will be coordinated by Nicola Terrenato, Professor of Roman Studies at the University of Michigan. I would like to thank once again all those who have agreed to contribute to this event. This workshop is also an opportunity to see again some of the colleagues and friends I've met during the BiGAr project, some of whom also participated in the research. For them, the thanks are doubled for the precious advice provided along the research path. I will now give the floor to Andrea Argenti, who was also one of the supervisors of my fellowship, together with Nicola Terrenato. And I would like to thank you both of them for mentoring, support during this precious experience. Thank you.